All right, so today's tutorial, we have two topics. Well, it's actually one, which is nonlinear system of ODE. So, and we have two, we'll teach you two methods of solving those nonlinear system of ODE. The two methods are the ones you learned before. The first one is called undetermined coefficient, and the second one is called variational parameter. So, I think your professor skipped variational parameter when you were doing higher order ODE, so I don't know. But we'll do two examples for both topic. So first we have undetermined coefficient. It's really similar to undetermined coefficient for single ODE. If your GT involves polynomials, exponential signs, or cosines, remember when we talk about exponentials, you might have hyperbolic function like cosh or like this, okay? And you can guess your particular solution takes a similar form as GT. So it's exactly like before, except now instead of just single, you have multiple, and now you have like your guess form should be like in vector form because you have vectors, right? So before you guess like a x plus b, and now your a and b are vectors, so it's actually a1 a2 x plus b1 b2 like this. So that's the only difference. Oh, that's not the only difference. Another difference. You're doing this on Thursday. Then what did you do last week and this week? Am I ahead? I'm ahead of your lecture again. Okay. So what did you guys do? I'm really confused now. Not much. So is there anything we talked about last week's tutorial? Oh, you did diagonalize thing? I thought you don't cover that in 244. Because last semester, yeah, you did? Okay, so because last semester I talked about it, and my students were like, oh, we didn't do this. We're not gonna do this. I was like, okay, so this semester they decided to talk about it again. Ah, okay. And for you, you didn't do it. So for Natalia's solution, for Natalia's lecture, you did it, but for Lean's session, you didn't do it. Then what did you guys do in Lean's session? Okay, so it's much slower than I thought. What did the other method? Solve e to the at. I thought we did that already. Didn't I covered the matrix exponential already? I see. So you guys are doing matrix exponential again, right? It's alright. So I guess I think so, at least in Natalia's session. Okay, so I'm ahead of your lecture, which is what I don't want to do. Can we try to get our lectures more organized? Well, you need to talk to your professor. I wish your lectures could be more organized as well, because I'm so confused what you guys are doing. Yeah, let's just talk about this, and if I have more time, I might just go back to do matrix exponential or something else. Didn't prepare for anything, because I honestly, because I prepared this because I checked the schedule. They said they will do 5.6, is it? Yeah, anyway, they said they will do 5.7. They said they'll do 5.7, so I was like, okay, I'll do 5.7. Okay, it's alright. We'll just do this. Okay, so it's exactly like before, except you need to keep the duplicated terms when you meet those. Oh, this should not be capitalized. Should be, yeah, like this. So remember when we talk about single ODEs, you might have duplicated terms, and then you multiply by t or x until it's not duplicated. But for system of ODE, you need to multiply as well, but at the same time, you need to keep the duplicated terms. Okay? Does that make sense? So for example, here's an example. Suppose g of t is this. Okay? U e lambda 1t, and this is the solution to the homogeneous system. So this is your complementary solution, and you see that, well, it's duplicated. So what you need to guess is you need to multiply by t and also keep the original term. So this is gonna make your life even harder because that's gonna make the computation even uglier. Does that make sense? Because you have one more term now. Okay? But it's just computation, so it should be okay. Again, I'll give you some time to work on this. Okay, I'll start I'll start with this. So this is your A, and this is your g of t. Okay, so you can write your g of t as 6 negative 10 t plus 0, 4. So you can consider this as a vector, so let's call this A. So this is AT plus B. Okay, and this is your g of t. So when you see this kind of thing, what's gonna be your guessing? So think about that, and I'll give you some time to work on this. The computation is really ugly, so hopefully you guys are okay. Okay, I'll talk about it again. So first of all, you need to solve your homogeneous. Okay, so make this be 0, solve this, and that's gonna be your complementary solution. Okay, what about this? Let's do the first one together, and I'll give you time to do the second one. All right? Yep, okay, cool. So let's do this. So it's exactly like before, except now you have matrix. So basically, you have a nonlinear system of ODE. You solve the not nonlinear, non-homogeneous system of ODE. So you solve the homogeneous one. So you solve for this first. You will get a complementary solution, and then you guess your particular solution based on this. So let's do that. So your complementary solution, you will have lambda 1 equals to 7. So I'm gonna skip the steps, and v1 is 1, 1. And lambda 2 equals to 2. So v2 is gonna be negative 1 and 4. So if I give you this, what is my complementary solution? So you have yc equals to c1 1, 1 e to the 7t plus c2 negative 1, 4 e to the e to the 2t. Okay, so if you want to write it as fundamental matrix, it's gonna be e to the 7t negative e to the 2t, and then e to the 7t 4 e to the 2t, and here you have c1, c2. and this is your T, and then C. So that's your complementary solution. Now you need to guess your YP. So you need to guess it based on this. So as I mentioned before, if you consider this as a vector, so let's call this A. So you have AT plus B. This, what is this? Negative 1 here. That minus is from here. Oh, it's negative, sorry, not negative 2, it's negative e to the 2t. Are you talking about here? Okay, cool. So yeah, it's linear, so what is gonna be my guessing? So my guess, yp equals to, yes, so it's exactly like before. Now you have linear term, okay, so your guess should be linear term as well. So you're gonna guess a1, a2, t plus b1, b2. Does that make sense? So remember before when we have undetermined coefficients, we guess based on what this looks like. So it's exactly like before, okay? Yeah, this is a guess for the GT, exactly. And what do we do next? You plug this back into this, right? Do we also need to multiply by x? Well, that depends on if here and here they have duplicated terms. Do they? Are they linearly independent? So look at your guess and look at the complementary solution. Do you think we need to multiply by x? No, I mean t here. Nope, yeah, exactly. Okay, so I guess this, now I need to plug it back in. So back into the ODE, you'll have, so y prime is this, right? So a1, a2 equals to 6143 times y, which is a whole thing. So that's gonna be AT plus B1, A1T plus B1, and then A2T plus B2, and plus 6T negative 10T plus 4. Okay, and then you solve this. So this is gonna give you 6A1T plus 6B1 plus A2T plus B2 plus 6T. And down here you have 4A2T plus 4B2 A2T B2 plus 3A2T plus 3B2 and then minus 10T plus 4. So this whole thing equals to A1, A2. Now you need to solve for this. Okay, so solving, I'm gonna skip that because, well, you just need to make those equal. And I'll give you A1 is, I'll write them down, but you don't need to do it yourself because that's gonna waste too much time. So you will need to solve those equations, but just show you this is gonna be really ugly because right now you have multiple ODEs. And you have 6B1 plus B2 equals to A1, 4A1 plus 3A2 minus 10 equals to 0, 4B1 plus 3B2 minus 4 equals to A2. So A1 is -2, A2 is 6, B1 is -4/7, and B2 is 10/7. And then you plug them back in. So this makes your YP equals to -2/6t plus -4/7, 10/7. Okay, so your general solution is your YC plus YP. So this, so Y equals to this plus this. So this is a final solution. It's pretty complicated. For the first row, wait. Hold on, why is A2 written twice? Where did I write A2 twice? Here? Oh, did I? 4A2. Is that B2? Wait, I'm confused. Like, okay, 4A2T plus 4B2 plus 3A2T plus 3B2. Oh yeah, okay, cool. Are we good now? Matrix multiplication. Wait, okay, so I did something wrong, did I? I did something wrong. Yeah, I did something wrong. Here should be A1, sorry. And B1. Is it? Okay. This times that, plus this times... Yeah. Now it's correct. Yeah, now it's correct. Should be A1 and B1. But yeah, I did it correct when I try to solve those. Don't know why I did it when I do it here. It's different. I wrote it differently, but the answer should be correct. Yeah. Any other question? Okay. Okay. Let's see. Someone asked something. Will we ever have to do this for a 3x3? Well, I don't know. I actually don't know. Well, I wouldn't give you 3x3, but I'm not your professor. Is your homework 3x3 matrix? Let me see. Nah, they were all 2x2, so you're good. Oh, yeah, everything's 2x2 matrix. Because 3x3 and then ask you to solve this, that's really mean. Okay, anyway, guys, try to solve this yourself. Example 2. I'll tell you that this example you will see duplicated terms, and remember, for system of ODEs, you need to keep the duplicated terms, okay? So you need to keep it like this. Anyway, I'll give you some time to work on this. From what I remember, if you use the second method, which is variational parameter, the computation is even longer. So if you could use this method, you try to use this method. Bring. Bless you. Did you guys hear him sneeze? Bless you. Okay, I'm just gonna take it up. So for this one, our eigenvalue, what is your eigenvalue? Anyone got it? Okay, eigenvalue, -1. Wait, did I write it wrong? Wait, hold on. Did I do the wrong question? Let's see. This might not be the question I meant to ask you to do, but okay. What did you guys get? Got disgusting fractions. Oh, okay, then I might made a mistake somewhere. That might be a typo. Let me check. That's probably why. Where did I find this question? I think it's from a textbook. Give me a moment. Yeah, I probably... This calc is not fun. Don't you think the whole course is not fun? It's not just this calculation. It's the whole course. The whole course is not fun. Not just this. The whole semester, what are you taking? I feel like, okay, for some reason, although I'm not taking any courses anymore, but for some reason, I feel like this semester I'm busier than last semester. I don't know if it's just me or anything. Like, it's supposed to be the same, right? But for some reason, I feel like I'm so much busier than last semester. And it's like, like, I feel like I'm marking all the time, and I'm still so behind on marking. Yes, yeah, this is supposed to -2. That's why. -2, 1, 1, -2. What's GCP? Oh, okay, let me see. Physics 241. What's DRE? GCP, the thermodynamics. Yeah, I took that course too. Drama for my humanities. Oh, I see. Yeah, I don't know. Like last semester, I feel like everything was okay. But I mean, I was pretty busy, but it was okay. But this semester, I feel like I'm doing work all the time, but I still have tons of work to do. It's really bad. Anyway, yeah, this is supposed to -2, so that's gonna make your life easier. Try this again. So for this, the lambda should be -1 now, I think. Let me quickly do it. 4 minus 2. Yeah, I think now lambda is 1. -1. Okay? And based on this, you can tell that, well, right now I don't need, because they ask you to find a particular solution, so you don't even need to find the eigenvector. Why? Because, well, you just need to know if your particular solution is gonna be linearly independent with your complementary solution. So if you are just being asked for a particular solution, you don't even need to find your eigenvector. Oh, but I want to write this as 2, 0, e to the negative t plus 0, 3t. Okay, so lambda is -1, which means your yc is going to be something like e to the negative t, right? And then something. So it doesn't matter what it is. You just know that, well, whenever you see e to the negative t, you need to times t because that's going to be replicated. So my yp guess is going to be, actually it should be xp. So xp should be a1, a2. So I'm guessing based on this. So I have e to the negative t. Here, the complementary solution will give you e to the negative t. So you need to multiply by t. So t, e to the negative t. And you keep the original one. So b1, b2, e to the negative t. Okay, and -3. Doesn't matter. Yeah, it doesn't matter. Because this is the only one that affects our particular solution. Well, shouldn't it be t? Where? Where are you talking about? B1, B2, T? No. This is a duplicated term from this. So I multiply T, but I need to keep the original term as well. So I'm not there yet. This is for this. Does that make sense? So what I have here is for this. I'm not there yet. Okay? So, and for this, what is this? This is a linear term. So what I need to guess is a linear term as well. So C1, C2, T plus D1, D2. Does this make sense now? So remember, you need to keep this term. So from the beginning, I said, okay, unlike single ODEs, you keep the duplicated terms. So you multiply by T, but you still need to keep the original term. Anyway, where am I? Yeah, and then you sub it back into the equation. So that's gonna be really ugly. Okay, I'll write it down, but we don't care about the computation part, I guess. So this is what I get. T e to the negative t plus a1, a2 e to the negative t minus b1, b2 e to the negative t plus c1, c2. And this equals to a, which is -2, 1, 1, -2, and times x. So times this whole thing. I didn't break them out because I'll do that later. So move it back a bit. This whole thing, and then plus 2e negative t, 3t. And this will give you, so yeah, it's bad. So you should pray that they don't give you 3x3 matrix. 1, 1, -2, a1, a2 equals to -a1, a2. And then here, -2, 1, 1, -2, b1, b2 equals to a1, a2 minus b1, b2 minus 2, 0. And here you can have -2, 1, 1, -2, c1, c2 equals to -0, 3. And lastly, you can have -2, 1, 1, -2, d1, d2 which equals to C1, C2. And after all the computation, this is what I get. A1, A2 equals to 1, 1, and B1, B2, I got 0, -1. C1, C2, I got 1, 2, and D1, D2, I got -4/3 and -5/3. Okay, and then you plug it back in. So plug those back in, you'll get your particular solution. But the computation part is not the important part. The important part is you need to know how do you guess this. Okay, so for the next one, I'm gonna skip this part. So I'm gonna skip this whole thing. You can read it yourself because I want to tell you that if you use matrix exponential, that is gonna make your life easier. If you don't think doing compute the matrix exponential is gonna be really ugly. Okay, so let's move on to example 4, and I want to show you. So I'm not gonna give you time to work on this, and I'm gonna show you if I use. So this is the second method. So normally, if you don't use matrix exponential, then you need to use this formula, or this formula specifically. Okay, but you need to calculate those using those. So you can follow that yourself. But my point is that if you use matrix exponential, it's actually gonna make your life slightly easier. Slightly. Okay, here it comes. So what I'm gonna do is this is your A, and I'm gonna compute e to the ax. So someone compute this. What's e to the ax and tell me. At, because we have t. Compute this. So I don't know which way you would prefer. Either you compute this and make later life easier, or you do the complicated thing. So it's gonna be a lot of computation either way. Give you some time and compute the matrix. Oops. Anyone finished? What is e to the ax? You forgot how to do this? Ah, no. Have to know. Yes, there are different ways. But either way, you need to know how to compute this. So I'll write it here in case we run out of time. If you use matrix exponential, then yp, I mean in this case is xp, equals to e to the ax, a t, here's t, and integral from 0 to t, e to the minus a s, and this is my g, let's call it gs, because I don't want you to put that in. So gs ds. So I'll just tell you what's the exponential. This will, you should get cosine t, sine t, negative sine t, and cosine t. Okay, and then you can use this formula, and that's going to give you e to the ax, at, and from 0 to t, and then e to the negative as times gs, so gt is this, so sine s 0, and then ds. So if you remember how to do matrix exponential, this is what you need to compute. But if you don't remember, it's going to be really, really ugly, which you probably don't want to do that. But either way is okay, unless they said you have to use matrix exponential, and they probably will, because it seems like your professors really like it. Sine s here, sine s, not negative. It's a bracket. Sorry, I'll write it more clear. Well, probably should use this. Yeah, this is better. There. Okay, so I'll convert this too, in case anyone cannot read my writing. Okay, there we go. So this equals to e to the at from 0 to t, and then e to the negative as. So that's cosine s, negative sine s, and then sine s, cosine s, and then you have sine s 0, and then ds. Okay, so that's gonna be, so cosine, sine, yeah, cosine s, sine s, and then sine s squared ds. Convert everything in case anyone cannot read. This actually looks bad. Don't know why it looks bad. Hello? Okay. Yeah. Don't know why this one doesn't work that well. There we go, there we go. Yeah. Wait, why did the sign switched? Where? Here? Switch from here? Minus from the exponent. Yeah, exactly. This equals to e to the at, and then you need to take the integral of them separately. So 0t cosine s sine s is 1 over 2 sine 2s ds. And then here, 0 to t, you have 1 minus cosine 2s over 2 ds. Okay, still a lot of computation, huh? And this is gonna be e to the at. This is gonna be 1 over 4, no, negative 1 over 4. Cos 2s from 0 to t. And here should be s over 2 minus sine 2s over 2, and it's from 0 to t as well. Okay, let me convert those. Didn't work. Come on, make it work. Wait, it didn't work, did it? Oh, it did. Nah, this doesn't work. Okay, I'm just gonna leave it as handwritten. Did I make a mistake somewhere? Sine 2s. Where? Is it cosine 2s? Let me check trig identity. It's possible that I make a mistake, but I'm not sure. Let's check. Sine cos 2 sine u cos u equals to sine 2u. Yeah, it's correct. It is correct. It is correct. So this will give you e to the at, and then negative 1 over 4 cosine 2t plus 1 over 4. And lower should be t over 2 minus sine 2t over 4. And then you need to do matrix multiplication. So e to the at is this. So let me make it smaller because I don't remember. Cosine t, sine t, negative sine t, cosine t. Times this. Still a lot of computation, but I guess it's slightly easier. And the final answer should be, so skip that part. And the final answer is t over 2 sine t, and t over 2 cosine t minus 1 over sine t. What's going on? Where are you guys talking about? Still here? Here to here? Let me see. Hold on. Wait, label it again. 2. That 2? Should it be for this 2? This 2? Yeah, it should be 4. Sorry. It is supposed to be 4. Don't know why I wrote T. Yeah, it is supposed to be 4. You are right. Okay. Any other question? Let me see if I can try to do this and convert it into math. Might work. Or no, I don't know. No, it looks too ugly. So let's just leave it like this. This is YP, or what is this matrix? This is your particular solution. XP, in this case. Yeah, they ask you to find a particular solution. So you use this formula. So this, using matrix exponential is gonna make your life easier. But the problem is some people don't remember how to do matrix exponential, so they might want to do the original way, which is this, but this will be really complicated. The computation is really, really, really ugly, because I tried this question and it took me so long to finish all the computation. I wrote like 3 pages. Let me see. 1, 2, 3. Yeah, I wrote 3 pages to finish all the computation. So I do not suggest you to use this way. If you could, use matrix exponential, okay? And also, if you could, if you can avoid variation of parameter, you can avoid it if possible. But I think your problem set asks you to use matrix exponential, so use this way. So not sure. I haven't tried your problem set yet, so I can't say if it's short or long. But anyway, that is it for this tutorial. If you're in my first tutorial, you may leave now. If you are in my second tutorial, hello. Be ready for a lot of computation. And yeah. Hello.